Dear students, yesterday in the last video we have studied this graph. Let us study the same graph in more detail just now. You can see here in this graph, you can see here that here we have the vapor pressure and here we have the mole fraction. Now you can see that here only the component 1 exists and component 2 is 0. Here the component 2 only exists and component 1 is 0. This is what we consider it as a solvent. This is what we consider it as a solute. The solute has a vapor pressure P10. The solvent has a vapor pressure P20. P20 is greater than P10. That means the vapor pressure of solvent is more than the vapor pressure of solute. Now what happens, as this as this solvent is there, we start adding the solute to it. So here the composition, what you can see, is 20-80. That means we have 20% of the solute and 80% of the solvent. You can easily understand that if we move from this to this, the total vapor pressure decreases from P20 to this. So as we keep on adding the solute to the solvent, the total vapor pressure decreases from P20 and it comes to this level. Again, when we make the composition 50%, 50%, then we reach this level. When the composition is 80-20, that means 80% of the solute and 20% of the solvent, the the P total reaches to this level. And when there is no solvent present and all the solute is present, it reaches to the vapor pressure P10. Here we understand about the vapor pressure contribution of component 1, and this is the vapor pressure contribution of component 2. You can see here at this point or at this point, there is no contribution of component 2 into the vapor pressure. But as the concentration of component 2 increases, the contribution of component 2 rises from 0 to this level. It goes up, and when at last it reaches to the P20, when there is no contribution from component 1. Same way, initially when we think about the component 1, then the component 1 has got the highest contribution, but as the concentration of solvent increases, it goes like this. Or in other words, as the initially the contribution from the solute is 0 here, but as the concentration of solute increases, the contribution to the total vapor pressure also increases, and as the concentration of solvent becomes 0 and only the solute is present, its contribution is highest, and that is what is P10. So this particular graph with the red dotted line represents the contribution of component 2 into the total vapor pressure, and this graph represents the contribution of component 1 into the total vapor pressure. And this is what it is, the linear graph that represents how vapor pressure increases from going left to right, or how vapor pressure decreases from going right to left. This is a linear graph, and that is why we can say that this solution follow the Rault law properly. Now let me explain the notes what I have written. I think I have written the same thing what I have explained. If we look at the graph, we realize that going left to right, the proportion of component 1 decreases. As see, initially it is 100 plus 0, 1 plus 2. 80 plus 20, 50 plus 50, 20 plus 80, and 0 plus 100. So initially vapor pressure is P10, which is for pure component 1. Now if the component 2 is added, which is more volatile, slowly the contribution of component 1 to total vapor pressure decreases and ultimately goes towards 0. The diagonal red dotted graph for component 1 I have already explained. At the same time as the proportion of or mole fraction of component 2 increases, its contribution rises from 0 to P20. P20 is the vapor pressure of pure component 2 or pure solvent. Thus, the contribution of each component to vapor pressure is because of its mole fraction. The minimum P total is equal to P10, that is the vapor pressure of component 1 or pure vapor pressure of pure component 1, and PT maximum will be is equal to P20, which is the vapor pressure of pure component 2. As the graph Pt is equal to P1 plus P2 is linear, we can conclude that total vapor pressure over the solution varies linearly with mole fraction of component 2. This is how we understand about the second conclusion from the Rault's law.